Today let us study yet another interesting property of chords of a circle. But we start with something very basic. What do I mean when I say that the distance between a point O and a line AB is 5 centimeters? What do I mean by that? Here I have taken a point and a line so that we can transfer the same concept to the center and a chord. But you can consider any two bodies, maybe your house and your school. When I say the distance between them is 5 centimeters, you will tell me what an ambiguous statement that is. Why? Because the distance depends on the route that you take. What if somebody takes this route and another person takes this route? So if this is say 8.7, this will be even longer. It will be say 8.10. So you will tell me depending on the route, the distance is going to keep on changing. But you ask the Google lady, the GPS on your phone, it will give you the shortest distance. So the GPS, when the GPS says distance, it means the shortest distance. It is the same in maths. Maths is also like the GPS lady. When we say distance, we mean the shortest distance, and when we say the shortest distance, we mean the perpendicular distance. Or in other words, try to make the English alphabet L. That is what is defined as distance. There. See? Here. Make a point L such that this is 90 degrees. Then this distance is 5 centimeter. That is what we mean. When I say that the distance from a point O to a line AB is 5 centimeter, it means that I can find a point L here such that OL is 5 centimeters and OLB is equal to OLA is equal to 90 degrees. I mean all of these things when I say the distance is 5 centimeters. Now let us transfer the same concept to a circle. So instead of any point and any line, you have the center and you have the chord, but the definition, the concept you have is the same. When you say distance, remember you always mean the perpendicular distance. But then when this whole scenario comes inside a restricted place, circle is a very restricted place, right? So when it comes inside a circle, you get one extra bonus. What is that? It is not only perpendicular, it will bisect AB. It will cut AB into two equal parts. Your AL will be equal to LB. That is something bonus, right? You will not get it at any point if you take any random point, because just look at this. If you take AB, its midpoint will come somewhere near here. I will name this M. Its midpoint will come somewhere here, but the perpendicular distance is somewhere else. But then in this restricted atmosphere of a circle, you will see that the midpoint and the place where the perpendicular meets both are same. We will prove it as a theorem, but throughout this lesson, remember, when I say distance, I mean perpendicular distance. I mean a line which goes and cuts AB into two equal parts. So the word distance, very simple, but means perpendicular and bisector. Please remember that. We will see the theorem and then go on to question answers. Now these are our two main theorems. We are going to prove both of them side by side. What do we have? You have a chord in both the cases and you have a line from the center. In this part, what do you have? What if that line is perpendicular? Then you have to show that it splits AB into two equal parts. But here what do you have? Again a chord. again a line from the center, but this time the line actually cuts it into two equal parts. What do you have to prove? You have to prove that it is perpendicular. Now we go on to the proof of the first theorem. You have to prove that L is the midpoint of AB, or in other words, you have to prove that LA and LB are equal. Now you remember what I told you in the earlier class? This is the topic that we are studying is circles, but then throughout we will be dealing with triangles and their congruency. So you need two triangles, and if this is what you have to prove, just add the same vertex to it and try to get two different triangles, one which will have this as the side, another one which will have this as the side. See, one which has LA as the side, other which has LB as the side. Then what is the only vertex which is left behind, only point which is left behind? O. So put O, get two different triangles, and as I said again, remember congruency is very sensitive to the order. Make sure you keep the same order. If you are coming OLA, then again take OLB. Don't go OBL. Don't go all over the place. Maintain discipline when it comes to congruency. Follow the same path, OLA and OLB. And now see the first two here and the first two here, OL and OL, that will be your common side here. This will be your common side. And what about OA and OB? What about them? We are dealing with circles, which means what? OA and OB are the radii, which means they are again equal. And what else is given? It is given that OLA and OLB are 90 degrees. So there, did you get your 3 points of congruency, your 3 statements on congruency? Two sides and an angle. But tell me, what congruency do you use? A side there, but you see the angle next to it, you do not have that. For two sides, this is what you should have. You should have two sides and the angle between them. The angle between them comes here. You do not have anything related to this. What you have is a side. You have missed this angle, then you have gone to the side. Then what do you use? You use the RHS congruency. Now what does your RHS mean? Your right angle, there you have your hypotenuse, there you have it, and any side which is OL. Remember, you cannot apply SAS here. Why? Because SAS means two sides and the angle between them. You have no knowledge about it. So by RHS you see that these two triangles are congruent. Again, remember, when we say two angles are congruent, we are not just talking about them. We are talking about 6 other congruencies. The first angle congruent to the first angle, second congruent to the second, third congruent to the third. Similarly, OL congruent to OL, LA congruent to LB, BO congruent to OA. We are talking about 6 congruencies. Take any one of them and say it is CPCT. AL, LB will be congruent, will be equal by the CPCT. Now this rule also follows the same, only one little different. Now we move on to the second theorem. What do you have here? You have that L is the midpoint. Now you have to prove that it is perpendicular. Consider the same two triangles, OLA and OLB. Remember, please keep the order. The first two, OL, OL, same. Why? Because it is the common side, and LA is equal to LB. Why? Because it is given that L is the midpoint. So these two are same. What about OA? OA and OB go in the same order. The first two, the second two, and the third one. What about that? Remember, the radii always equal. When you have two line segments whose one endpoint is the center of the circle and the other endpoint lies on the circle, then we are talking about radii which are always equal. So you have three equal sides, so it is SSS, and these two triangles are congruent. When we say they are congruent, we have 6 other congruencies. Take whichever angle, but exactly in the same order. First angle congruent to first angle, second angle congruent to second angle, third angle congruent to the third angle. Now look at the second angle here. What is it? OLA and OLB. Take the two second angles, they will also be equal. So let me name them X. So this is an X, this is another X, but they form a straight line, which means added they give 180 degrees. That means 2x is equal 180, and that means each x is 90 degrees. So what does that mean? Whenever you hear the word distance in this scenario, which is from a center to a chord, then remember that it means two things. From the center to a chord means two things. It means that it will be perpendicular. It means that it does bisect. Now before we go on to our question answers, please look at this very simple question. Now we are going to do the same routine throughout for every question. Why? Because this whole chapter, this topic is about the distance from the center to a chord, and whenever that happens, whenever you hear the distance, you should remember two concepts. One, it is perpendicular, and two, it bisects. So please remember both of this and try solving this question. What do you have? You have a chord whose length is what? 10 centimeters. Then you have this line. Then what do you know about this line? It meets it at right angles and it bisects it into two. So if this whole thing is 10, then just this will be what? 5 centimeters, half of it. Then what is the radius? The radius is 13 centimeters. Now what do you have to find? You have to find the chord length. So you see what is happening here? You have to apply the Pythagoras theorem. Now just by looking at it, you should be able to say that the third side is actually 12. Now these are some examples of numbers which will follow the Pythagoras theorem. If you see, the largest of them will always be the hypotenuse, because the hypotenuse is always the largest side of a right angle triangle. The other two, 3 and 4, 6 and 8, 5 and 12 will be the other two sides. You can check it if you want. Find the square of 12, it is 144. Find the square of 5, it is 25. Add them, you will get 169, which is the square of 13. So remember these numbers. I will just write them the next time we see it. But just see, there are some numbers which always follow the Pythagoras theorem. But always remember, the greatest one should be the hypotenuse. Don't mix it. It will not come the other way. These two squares added should give the hypotenuse square. Now look at this question. You have two parallel chords AB and CD. One of them is 12, the other is 6. Which one will be greater? The one nearer to the center will be greater. So this should be your CD because it is 12 centimeters, and the one which comes farther away from the center will be smaller. So this will be your AB, whose length is what? 6 centimeters. And next, what do you have? The distance between them is 3 centimeter. The minute you hear distance, you should know that if it is from the center, it will bisect and it will be perpendicular. So instead of just taking this distance, why don't we take all the way from here? then you will get two beautiful right angles. Why? Because whenever we say the word distance, it means perpendicular distance, and when it is a line from the center, it also means that it bisects into two equal parts. So see here, you get two right angles here, and not just right angle, it will bisect also. So instead of 6 centimeter, we just have to take 3 centimeter, and instead of 12 here, that also cut into two equal parts, which is 6. Now the distance between them is 3. What about this distance? We have no idea. Let us take it as x. Now what is asked? What you have to find is the radius. Now we have a problem. Why? If you have one unknown, you just need one equation to solve. Now you already have an unknown. Now you are going to have another unknown. For two unknowns, you will need two equations. So why don't we consider two different right angles? Then we will get two different equations, right? Consider this right angle and this right angle. There. Shall we start? Suppose the point where it meets, let it be P here and let it be Q here. Now consider the first triangle OPD. What do you have? It is a right angle triangle, which means with your eyes closed you can apply the Pythagoras theorem. What is the hypotenuse? It is R. So take the square of R. What are the two sides? X and 6. So the square of 6 is 36, 36 plus x square. You have got your first equation. But then see the two unknowns. There is no way you can solve it with just one equation. You need another equation. Now consider the bigger triangle. This one. OQB. Same hypotenuse. So you have the same R square. What are the sides now? One side is 3, so its square is 9. But the other side, what do you see? This much is 3, this much is x. Together it is 3 plus x, the whole square. There you have your second equation. Now you have two equations. Did you notice one thing? Both of them have the same LHS. If you have two equations with one of the sides equal, 4 and 4, what does it mean? It means x is equal to y. Similarly, if both of these are same, then you can equate these two. When you equate these two, what do you get? 36 plus x square plus 9 plus, open the brackets, a plus b the whole square, which is a square plus all of this multiplied, 2 into 3 into x, which is 6x plus x square. You see this? And x square here and x square here, two equal terms, which means you can remove them. There. Solving this equation, you will get what? 6x is equal to 36 minus 18, which is 18. So x is equal to 3. This much is 3, but that is not what you want. You want the radius. So substitute that value here. If x is 3, this value will be 9. So 36 plus 9 is 45, but you have r square is 45, not r. R square is 45. So r will be square root of 45. 45 is what? It is 9 into 5, right? So that its square root will be this. This will be your answer. This will be your radius. Now look at this question. You have two different circles. One with the radii 10, another one with the radii 8. Obviously, this is your smaller circle with the smaller radius. Then their common chord is 12 centimeter. What do you know about a chord? Its end points should lie on the circle. So if it is a common chord, it means the end points should lie at the point where it can belong to both the circles. So this is exactly where your common chord is going to lie. Let it be AB. So when we say the common chord AB, it means that its end points, which is what? A and B, lie on both the circles, and this belongs to both the circles, which means what? Both of these centers, if you take a line from them, the perpendicular distance from them, this will bisect AB. So shall we go one after the other? First we will go to the smaller circle and see what happens here. There, a perpendicular distance, I will name it M. What does our theorem say? When it is perpendicular, it will also bisect, which means it cuts it into two equal parts. The whole of AB is 12. That means just this. MB is going to be 6. What about the radii? The radii is going to be 8. Now, solve this. You will get what? You will get OM, right? But then OM is not what we want. We want whole of OO dash. We need the whole of this. Then how do we do that? Again, draw a perpendicular. Where will it go and meet? It will meet it exactly at M. Why is that? Again, the same rule. If we draw a perpendicular, it has to go and meet at its midpoint. So this line will also meet at its midpoint. You will have another right angle triangle, but this time with a different hypotenuse. Only this side will be same. Rest of all is going to be different. This is going to be 10. You see, it is a different radii. OB is a different radii. O dash B is a different radii. So, you have two sets of Pythagoras theorem. Solve for this, solve for this, and add. Shall we do that? What do you see here? Two different right angle triangles with two different hypotenuse. What is missing? Both of them have one side 6, but the other side is missing. So here OM, apply the Pythagoras theorem. What do you get? The hypotenuse square would be the sum of squares of these two. So your OM will be square root of 28. Now look at this one here. The square of the hypotenuse, which is what? 100, will be equal to this, and you get your O dash M is 8. Whenever you have to find the square root of some number which looks like this, for example, say a number which looks like this, say 52, approximately you can find out what its square root is. What you have to do is just go to the smallest square before this number. What is the smallest square before this? 6 square is 36, 7 square is 49. The next square is what? 7 square 49. The next one is 8 square, which is 64. So this 52 lies between 7 square and 8 square. So the square root of this will be 7 point something. That will be its square root. Without calculating, without going into details, it will be 7 point something. Similarly, you can find that here also. It is square root of 28. Now go to the smaller square. 3 square is 9, 4 square is 16, 5 square is 25, and then the next square comes at 6 square, which is 36. So this lies between the squares of 5 and 6. So its square root will be 5 point something. 5 point something plus 8, so the whole distance is what? It is 13. Add both of them, you will get 13. You have two concentric circles. What does that mean? They share the same center. But why do they look different? Because they have different radii. Maybe this one has just 4 as the radius, but this one has 10 as the radius. Maybe they have the same center but different radius. That is why they look different. Now you have two chords. One chord is BC. You see here, its points lie on the smaller circle. So BC is a chord belonging to the smaller circle. Look at the bigger chord AD. You see where the points are lying? It is lying on the circumference. So AD belongs to the bigger circle. It is a chord of the bigger circle. Now what do we have to find? we have to find this distance A, B and C, D. How on earth do we do that? What is our theorem? What are we studying here? We studied that if we draw a perpendicular distance from the center, not only will it be perpendicular, it will cut the chord into two equal parts, which means if you consider the bigger triangle and the bigger chord, which is what? AD. It was 12, but what has this line what did this line do? It has cut it into half. So suppose this point is M. So what do you have? Your MD is now just what? Half of AD, which is 6 centimeters. And same with MA. MA and MD has now been cut into two equal parts. Now look at the smaller circle. What does this do? This also cuts this BC into two equal parts. And what do you have? The whole of BC is 8, which means what? MB is equal to MC is equal to what now? Half of 8. Now, just like you do with everything else, subtract this from MA, subtract BM, take away this BM from AM. What is left? Only AB is left. Now, from this MD, this much is MD. Take away MC. This is MC. Take away MC. What are you left with? It is just a CD. Now, 6 minus 4 is 2 centimeters. There you have your AB. This much distance is 2, this much distance is 2, and this is exactly what we wanted. Today we learned yet another interesting property related to the chords. Take any line from the center to a chord, then if that line is perpendicular, if that line makes 90 degrees, then what? It will bisect. And if that line bisects, then it will be perpendicular. Or in other words, if you see the word distance from the center, remember it works only from the center. If you see the word distance from the center to a chord AB, then with your eyes closed you can say two things about that line. It will be perpendicular and it will bisect AB. So that is all for today. Inshallah, I'll meet you again. You take care. Assalamu alaikum.